All right. So, Happy New Year, Mr. Christian.
Hey, Happy New Year, Mr. Cardozo.
It's been a while, but I hear that we're going to do some cool stuff.
Yeah, so sadly, last stream, uh, we had to cancel it. You couldn't attend, and I tried to do it, but my internet failed. We will still do the parallelism with Flax stream. That is not gone. Just for those who were interested in that topic. Uh, we will do it probably later this week or next week, uh, and because I already had everything prepared.
Sorry,
But David was very interested in this topic, so we are basically going to go through this library that I haven't like fully announced like on Twitter. Uh,
but it
but
was announced on the Google Developer Expert group, if I'm not
yeah,
mistaken.
yeah, I've shown it to a couple of people,
hmm
and uh, we also discussed it in a little bit in the previous stream. But like I expect to do like a formal announcement when I finish some of the README and
Perfect.
the getting started. But today I think we will.
But I think it's good that if we can do like an introduction. So Ciclo is this. So what is Ciclo, Mr. Christian?
Yeah, so let me let me share my screen. So I'm gonna show you the repo, and we can discuss like
hmm
uh, maybe why this exists, right? So I think the link is in the description of the stream. You can check it out. Basically, Ciclo is like a setup of training loop utilities and abstractions. So it's purposely defined very broadly because uh, my idea with Ciclo is that it's like more of a low level thing that can eventually composed into more like automation similar to what you get in PyTorch Lightning and Keras, but initially it is just kind of trying to help during the, let's say, current way to define training loops in JAX, which is basically just code it yourself by hand. So the idea is to provide like let's say thin layer over coding it by hand, and then if you have the proper abstractions, the idea is that eventually you could get to more automation. uh,
So it's in the same spirit of PyTorch Lightning, which is battery included, but you can just change certain things that you can override, or you need to. It is what I'm trying to ask is it very opinionated or it's very bare hands?
this
How
is
do you see it?
basically, I think, the least opinionated thing abstraction you can have.
Hmm.
Like I'll scroll down in a bit and we can see how it looks, but it is basically a very thin layer over a training loop, and it's very flexible. So PyTorch Lightning and Keras, they kind of force you into certain patterns, or I mean they have a pre-specified notion of a training loop.
hmm
Here there is no like like template of what it should be. You construct the template. That's kind of the difference. Second difference is that it's functional because
JAX.
because JAX is functional, and it was very important that it was functional first, let's say.
Hmm.
So that is something that is here. Obviously, I don't know, people, if they searched a bit in the ecosystem, they might know uh,
CLU?
ele- elegy.
Ah. Mhm.
So elegy is also like another framework. Me, David, and other folks contributed to a while ago, and continued improving it. Uh, so like the problem I think with elegy was that it started being high level, and then it tried to be more flexible. And then, yeah, I couldn't use it for certain things. So Ciclo is kind of okay. Yeah, let's start uh, low level and try to build up. And it's worked, I think,
And
a
one
little bit
one
better.
one small thing, one small thing. And what is the relation with CLU, the common loop utilities from the Google team?
Yeah. As you'll see in a bit,
Mm-hmm.
Ciclo has a couple of utilities which are kind of like callbacks,
Okay.
and CLU also has like those utilities. The idea initially, because this was partially inspired on CLU, was okay. They should uh, like you should be able to use any CLU callback within Ciclo.
Right.
Like it's supported, or if it's not supported, it should be supported. But right now, some certain things like their periodic actions is supported. I don't know if people are very familiar with CLU, but I used it uh, quite a bit. So there is support for that. And okay, yeah, let's see like what we're proposing here. So
Mm-hmm.
I think this piece of code might give like 90% of the information.
Right.
So okay, in JAX we usually create like a training step. Regardless of the framework you use, you have something similar to this. It might contain other stuff, but you basically have your state and your data as inputs, and then okay, this is part of the framework, but the idea is that you return like some logs, usually metrics, and then like the updated state, which I guess it's what you get after backprop, and this kind of like the template of like a training step, very very abstract. You can even forget about this, just the general signature.
I think, Christian, do you mind if you can refresh the page? Because I think we are seeing an updated version of the loop.
Oh yeah, sorry.
No problem.
We updated it just before this. Yeah. So in general, this
Hmm.
uh, just kind of can be anything. So this works for, as far as I know, all existing JAX frameworks. This pattern, and so okay, the idea is we have like a loop function, which is kind of a mini language, so let's say, where you construct the training loop using a couple of utilities. So uh, as you see here, you sort of specify like, okay, there are some schedules like when things happen, and then on the right you specify like what is going to happen.
Mm-hmm.
So obviously that the training step is something that you want to happen. In this case, every step. And then there's a couple of things you also want to happen every so often. Uh, so like for example, maybe you want to checkpoint every 1,000 steps. It could look something like this. So there's the checkpoint callback. And then let's say every step you want to you want to show like a progress bar. So like we have the Keras progress bar here implemented,
Mm-hmm.
and uh, there are obviously I mean the utilities that Ciclo provides should be mostly callbacks and maybe some other fancy schedules. And this is more or less a training loop. And the training loop, what it's going to do is that it's going to thread the state around each of these callbacks. Obviously, I think in this case, only the training step is actually going to modify it. And it's going to consume the data. So we have an initial state.
Where is the iterable? Ah, okay, it's the second argument for loop, right?
So
Yeah.
so yeah, we have like a state. We have a like a data set which is an iterable,
Mm-hmm.
and this kind of a list of tasks. Okay, we also have like a stopping condition, uh, and this is a function. So this function just returns the like the final state, like history, which is kind of a list of all the logs that we accumulated, and something related to how much time uh, passed, like how many steps, how many contains information about time. So
Mm-hmm.
this is right now how it looks. And you I mean the Ciclo, the idea is that these are a set of utilities. So while the loop is very convenient, you can always break out of the abstraction and then just use these utilities on their own. So if we code this same thing but we code it ourselves, it could look something like this. I mean, here we're just assigning the callbacks and the schedules to some objects at the beginning, because we cannot use them just in line. And then we're just going to call to do like, yeah, like a very basic training loop, like okay, yeah, there's a bit of framework specific stuff, like okay, I create like a logs object, but then here we just call the training step, and based on the call checkpoint schedule, which is every 1,000 steps, we call checkpoint, and we always call chaos per. So this is just exactly what we have here, plus some extra bookkeeping, like creating the history object, which accumulates the logs. And then yeah, we get parity. These two things are exactly the same.
One question though, it's that it looks like when I'm breaking out the extract the when I'm in the Python training loop, if I call cyclo.logs, I create the log. So in every single elapsed batch, it's going to create the logs.
Yeah. These logs object is like the logs of each step, and
Okay.
and these are
Ah, the
updated.
logs update.
Okay, there's a bit of magic going on here. Is some
Yeah.
syntactic sugar, but ultimately the logs are committed to the history, which is just kind of a list of all the logs. And
Makes sense.
yeah, this is what you get. So this uh, like important thing is that like all the useful stuff, like the schedules and the checkpoints, they can be used either in a custom training loop or in a like, or in the loop abstraction, let's say.
Makes sense.
So you are never like uh, restricted in that sense, but obviously this is shorter, as you can see. So that is kind of the spirit, and well, in the future, the idea is to add a little bit more support for maybe specific frameworks, or maybe have a less generic loop abstraction, but maybe like a fit abstraction,
Hmm.
like more like well, if what
Is
Keras and PyTorch Lightning do is what you need, maybe it can be simplified. I don't know. So yeah, this is the basic idea. And are there
not yet. No worries.
yet? Okay. So yeah, my idea was, okay, maybe we can code something from scratch just to see how it works.
Mhm.
So okay,
Actually,
I'm gonna,
would you mind if we can augment the font size and reduce the menu bar? That's good.
yeah. So okay, just gonna cheat one time
Hmm.
because I don't want to remember this. Uh, yeah, I'm just gonna cheat with
TFTS.
the TFDS, but otherwise, so yeah, we're just gonna like, let's say, solve the MNIST as usual. So okay, the first thing we do here is obviously import library. Uh, so by convention, you just import Ciclo as Ciclo. By the way, Ciclo means cycle in Spanish, and
Oh, good.
it was a name that was available, so it was good. And yeah, maybe, yeah, let's. So we're gonna solve the MNIST, and we have this, let's say, code ready to create the dataset object with the MNIST. Um, okay, yeah, I guess we can create like a sample. Okay. Uh,
Do you want to keep using Copilot?
but not as numpy. Yes, train dot as numpy next. uh, so I guess let's use it for this. Create a 3 by 3 grid object. Nope.
No,
Uh,
Alt Enter or what?
using two slots. AX. Okay. Uh,
I think
okay.
that you will need to train to bring matplotlib into the yes into the
Yep.
context.
Matplotlib.
Just before you jump into that, would you mind if you can just close the terminal side?
Okay, yeah, sure.
Mm.
Okay, so let's hope for some autopilot magic. Uh, is this right? I'm not sure this is right. Let's see. No, this is wrong.
The figure object is not scriptable, so the AX.
uh, let's see. Maybe this is like this. I don't remember. I was just hoping we got some Copilot magic here.
No, seriousness. Yeah, AX axis and figure. That's right.
For no, this is not right. This is not right either. Okay, let's cheat again because we already had this on our last stream in the terminal. I wonder why it worked last time we did it.
Didn't have any context for Ciclo, so it was thinking that maybe it was a high level library for Matplotlib.
Yeah, maybe. Okay, actually, yeah, we're gonna do a lot of the stuff here. It's a different
This is
API. Okay, it's slightly different. So,
AX.
okay.
Voila. But
It was fig comma access, not access comma fig. Okay.
it was this. It was switch on the axis. Yeah, cool API, the Matplotlib, huh?
Let's just put like a title set text, something like this.
Mhm. Would you mind again closing the terminal?
Yep.
Yeah, gotcha.
Okay, so yeah, just kind of DMness. So let's see. So we we have to define our framework specific stuff. So maybe let's do it very quickly. Let's import flax dot linen. So let's use flax, and then it's from flax dot uh, training dot train state. So yeah, not all frameworks have this train state notion, but you can just the idea is we're gonna pack all the JAX state in a single object. That is kind of, I mean, one I guess API choice that Ciclo is making. You can always do this because you can always just put everything into a tuple, which would be fine, and that works with any framework. And most frameworks have a way to create like some Py3 structures, and then you
Hmm.
just use that. But okay, let's create a linear classifier, I guess.
With
Uh,
the compact.
so this is fine. We're just gonna have probably 10 classes, and this is gonna just flatten it. So, like, okay, Bravo Copilot. We can create our module, and then maybe next thing we have to do is initialize it. So, usually you create the variables, but here we don't have RNG, so this should be something like, okay, we have to actually import JAX, and let's import JAX dot numpy. So now we just, okay, thank you. We just initialize with like a random key and then some sample data. Uh, so this is good enough. To to initialize our model. Okay, this is flag stuff, but all the frameworks have to initialize
somehow.
somehow. So the thing we're gonna create now is okay. Let's create like a state, and okay, we did this in our previous streams, so uh, like you can also take a look at that. Uh,
It's most of these train state everything. You can take a look at Beric's example of JAX and also Flax. So no worries if you think that this is not this is not part of the library. So no worries.
yeah, this is just like optax. I mean, flax stuff. So yeah, here we're just initializing, and our goal was to create a state, which is a thing that you'll see we're going to use to create the training step. So I think this is enough. Like, okay, we have our parameters, we have our optimizer. Let's just run this. So this part is obviously the framework specific stuff by the fact that we chose Flex, but I don't know, maybe in the future we can choose Equinox or
Hmm.
Haiku. Um, Next thing we're gonna do is just create like a training step. So
As usual, you take a state and batch, which is
okay, let's turn off Copilot. So okay, here we're gonna create take a state, and this has to be a Python inside. Well, there has to be a Python because it's gonna be JIT, and this part is the batch, which in this case also has to be a Python.
Mhm. Just beforehand, what is the signature? So this function should return what type?
So in this case, we are going to return. It's just if we go back to documentation, we want to return logs and like the new state. So let's just put here what we want to do, like logs
Hmm.
and state. This state obviously would be the updated one. Um, I'll discuss a bit like there's a bit more flexibility to these functions that go into the training loop. You can yeah you can change so it doesn't have to be this. Um, let's maybe let's quickly view that part.
Hmm.
The general signature is actually this one. You can you can request either zero, I mean 0, 1, 2 until 4 arguments. You will get the state. The second one will be the batch. If you request a third one, it will be the elapsed, and if you request the fourth one, it will be the loop state.
What is
Uh,
this? What is the type of this loop state?
the loop state is like a special object because it is not uh, it is not a JAX like object. It's not a pie tree, so all of these
Hmm.
should be pie trees that have well JAX types that
Constraints.
JAX
Mm.
recognizes, like numpy arrays and that kind of stuff. But loop state is not, so you have to be aware of this. In general, for the training step, you should never request the fourth argument uh, because it doesn't make a lot of sense. So
So imagine it like it's telling me it's like it pass information about if it's training, if it's val or something like that, or.
this is just like it's a stateful object that contains everything that is happening in the inside loop,
Hmm.
but like it is useful if you create functions that you want to use them for side effects. So if you're not interested in the yeah, if you're doing like a side effect, maybe you want to look. So now you're like in a pure Python world, then you might want to look into what's here and update it. And so for more general non-JAX functions, which are also part of a training loop, you can request it. For pure JAX functions, don't request it. And then the returns is a little bit more general than what we've seen.
Mm-hmm.
Uh, like, okay, you can return logs and state, like a tuple of logs and state, as you saw, but you can also omit either one. So you can say like non comma state, or yeah, you can omit them if you want, or you can only return logs, or only return the state, or return none. So it's kind of very flexible,
Yeah, makes sense.
because sometimes you just want to update the state. You're not putting logs, so it makes sense to just return the state. You can also return logs, or if you're doing only side effects, like I don't know, for example, maybe just logging stuff to weights and biases, something like that. Then you want to have like a callback that actually doesn't update anything. So none except is a possible return. That is in general. So like, okay, we're just gonna create a function that adheres to that interface. And yeah, accepting state batch and returning log state is good. So okay, here we're gonna have let's first get our inputs and our labels, and then let's just extract things from our batch. So TensorFlow datasets returns like a dictionary, so with image and label. So let's just have that around. Okay, and the usual way to create like the train step that we saw previously was, okay, let's create like a loss function that has the params, and then okay, we're gonna call the forward and get our logits. So we get the apply function,
Makes sense.
and here we're gonna pass the params that we get here, and with those params plus our inputs, we're just calling the forward function. Now we we have to get
Appl
the loss. Yep.
no, no, go for it.
So for the loss, Optax has the soft max cross entropy with integer labels, super long loop, and this accepts the logits and the labels. So we're good with this, and yeah, let's just calculate the mean, and uh, let's return the loss, and let's return the logits like as a second output. Okay, so this kind of the loss function. Now we have to differentiate with respect to that, and get so we're going to request the loss and the logits. So we want the gradients, right? That's kind of what we want, but we're going to use jax dot value and grad uh, of this loss function, and we're just gonna say that it has aux, and then Okay, just for clarity, this returns like the grad fun, and then the grad fun, we just pass the params. Okay, which is in state.params. And we should get back this. So with the gradients, so this state has we can update it by applying the gradient. So it has a apply gradients. And okay, this is like flags specific stuff. But okay, yeah, we did gradient descent thanks to optax and flags, whatever. That is the first thing we need to update our state. Second thing, we want to get some logs. So create logs. So uh, Ciclo has this logs utility. This is really just like a dictionary of string
To list of
to another
ah,
dictionary of string to any.
hmm,
It's kind of this interface. So it's like a nested dictionary that uh, has a couple of collections. So you can construct the dictionary as a normal Python dictionary, but then yeah, well, it gets a little bit verbose. So the Ciclo just has some shortcuts. Uh, so one is we can add a loss. We're gonna add a loss to the logs. And we're just gonna say okay, name it loss. Uh, give it a better name, but let's just name it loss. And we can also can also add like a metric. So for example, let's add accuracy. And for the accuracy, okay, I think we can code it in line. It's something like the mean of
square.
the the argmax logits dot argmax uh, in the axis -1 when they're equal to the labels, something like this. So yeah, this is how you code accuracy very simply. So yeah, okay, yeah, you can create your training step in whatever framework. Important thing is that you just have like a state, and then you return like the new state, and that is it. So yeah, now that we have this, we can actually go back to the Ciclo part, let's say. So okay, let's construct a training loop. So uh, simplest training loop is just uh, calling Ciclo.loop with okay, what are we gonna have here?
The
Our initial
state
state.
first.
So this is our initial state that we already have. Then is the data set. So
The iterator from TFDS.
yes train, and then we have to uh, as a numpy. It's not helping creator like this. And here
The mini
in
language for for
this kind of
specifying a loop.
yeah, this is the mini language. So in the mini language, okay, we want to run our training step like every step, and So in the documentation, you see, okay, every step, run the train step. There's some sugar which I'm going to use the sugar that you can omit list if you only have one. In general, it's a list, but if you have one, you can omit the list. And let's see. Okay, maybe let's just do something like this. Let's have like a training step, and 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 so simplest loop. Let's just have a training step and a progress bar. So Era's progress bar is, I think it's the most useful one. So we can have like a total, and then let's see. Let's train for 1,000 steps. Just and then stop here also like 1,000. So let's see what happens. So let's, okay, we missed a comma. Okay, it's training and it shows the accuracy.
That's good.
Um, okay, there's I haven't made this. Okay, I wanted to do an update so it shows the losses as well.
Hmm.
So there's two options. We can add like just add the loss as a metric. For now, I think I'm gonna change it such that it shows any scalar. Um, okay.
Hmm.
Actually, okay. There was a shortcut for this. You can automatically add the metric,
Perfect.
but I think that's subject to change, and I think, yeah, you shouldn't need to specify that you want to show the loss. So okay, hopefully trained. I don't know why the loss is so high. Let's train again.
Think the the optimizer is not doing their job. Can we take a look at the model, maybe?
Uh,
Are we then shape up, down, 1 point?
I think it's fine. Let's do something like this. If create state, just so we know that we have like an initial state here. And let's see how it evolves. Non-type. Okay, we forgot to return it. Yeah.
Hmm.
You know, the loss is definitely going down.
Now.
So, yeah, let's maybe add a couple of more steps. So, let's see. Total steps equals 10,000. So, okay,
Yeah,
yeah.
going down.
Oh, yeah, yeah, this is kind of the most basic uh, like training loop you can request. Obviously, this is kind of a linear classifier, so it doesn't reach. Um, it doesn't reach
State of the art.
state of the art, but we can check what is happening. So one of the nice things about history is that it has like a small API. So we can what is history is just all the logs. So if we try to print it, it might be super big, but it just has all the, so you can see here has losses, metrics, and basically, yeah, everything we accumulated. So this is a list of dictionaries, but it has an API, so we can just extract like things into separate lists, so we can plot it. So and you're like, okay, we want the steps just to show the training step. Um, we can omit it. Yeah, maybe let's omit it. Let's just request the losses and the accuracies history, and this has an API which is collect. So
Hmm.
I mean, you can do it yourself, but this is like a nested list of nested dictionaries, and the the API is that you can say just the name of these keys, and as long as they are not repeated in different collections, you won't get like an error. Else, you will have to specify the collection as well. But so we can do something like this, and then we're gonna collect that, and yeah, having that. Okay, let's see.
Multiple collection for losses.
Okay, yeah.
Hmm.
Okay, so we do have one repeated. So
You
I
need
know.
to.
So the syntax is that you just put like matrix dot,
Hmm.
or you because this one is repeated. But okay, it found it. So now we have these two lists, and we can just plot. So
I think
uh,
we could activate Copilot for this.
yeah, let's activate Trusty Copilot.
Plot loss and accuracies.
Okay, yeah, thank you. Uh,
Thank you.
Matplotlib Copilot. It's amazing. So yeah, this is kind of what we expect. Yeah, the loss drops until it reaches like a minimum,
Saturation. Hmm.
and then the accuracy also saturates at some point. This is okay. One thing about this is that yeah, obviously this is very noisy, and that can be fixed in various ways. So okay, David, I don't know how much time we have.
We have 10 minutes left, so my thing is that maybe we'll reduce the total step and let us add something to the like every 15 seconds, every 15 iterations, we save a checkpoint, something that shows that you can do this kind of um, smart smart scheduling.
um, we can also define like like a validation loop.
Okay, that will be good. Like every 100. Um, yeah, that could be good.
Okay, so for a validation loop, we have to do a couple of things, but let's see how that looks. Uh, so we need a validation dataset. So DS valid. Uh, what's
Test,
your test?
test, yes. And then
Okay, here. Okay, we we don't repeat because this is validation. We don't shuffle because it's validation. We batch and then we uh, drop remainder true, prefetch
And
one.
prefetch.
Okay, so
This
yeah,
is this build.
we need this. Second thing we need probably because we want to accumulate. Uh, we want to accumulate the metrics because we're gonna So when you're doing validation, you need to calculate like a metric over the entire train validation set.
Mm-hmm.
So we're gonna use CLU metrics. So from CLU metrics, we're going to import accuracy. So we're gonna
Yeah, we're going to save some lines of code by creating these objects.
I'm gonna shoot some CLU magic. I'm going to do here.
Hmm.
Uh, and we also need to create like a custom training state because we need to add the metrics. So from flags the training, the train state, import. Okay, so we already have this train state, but we need to redefine it. Import train states. So let's take out this. And okay, first let's define the metrics. So I usually create something like this class metrics, and that is a collection.
Hmm.
Okay, this is super smart. Okay, these, okay, no, it's not that smart. These are actually types. So they don't have like a concrete value. So this is just like this is a data class. Actually, it's a common error. I have to send a PR to CLU, but for now, we have to
From
from
CLU.
flags import struct. So we have to turn this into a data class.
Mm,
If I send a PR, this won't be needed, but for now it is.
but I don't think that they are setting PRs for CLU.
No, I know the person who works there who created CLU, so I already discussed with him this change,
Okay.
so that is fine. Uh, okay, yeah, we just created this. The only thing is from output uh, loss. Okay, maybe in a future stream I explain CLU a little bit better.
But this is a little bit of boilerplate that it's defined on the first notebook of CLU utilities. No worries, it's not that hard.
That is pretty common.
Mm.
I know. Let's see, it created a couple of stuff, but I don't want that. Actually, the reset metric one is we should create something like this, but outside.
Hmm.
Okay, so we created like a custom. Let's let's actually let's define this in a bit for now. So one thing that we need to do, let's format this. Uh, so we we need to so we added metrics to our training set, and the metrics in CLU are defined like this, and they're a data class, and we can pass it to the train state, and that is fine. What we have to do is okay, actually add them. So the proper API is not create; it's empty. I'm curious what create does, but it's actually empty. So this creates the
The
metrics
metric.
in a like an initial state. We do need a way to reset them because we want to reset them every time we enter like a new validation loop. We want them to be to reset themselves. So uh, what we want to do is that we're gonna create like a reset metrics function, and okay, yeah, it's exactly this. It will just replace the metrics with an empty one.
Emptiness.
So okay, I think this is enough to create like a validation loop. So okay, we can switch things around a bit. First, every step, we are going to.
Does it not need to be on a list? So if I give you one, he will be able to understand that.
Yeah,
Okay.
it can automatically infer that, and
Hmm.
here we're going to create like actually like okay every
100.
let's see maybe every 1,000.
All right.
Uh, we're going to do something different, which is that we're going to run an inner loop. So an inner loop is just a callback that accepts a name. We're gonna call it valid, and then it expects a function that uh, will execute inside the inner loop. So it takes the state at that point, and it should return the same stuff that a loop returns. So it's actually just another loop inside the the outer loop. So okay, we have a loop within a loop, and inside this loop, we're going to do like a couple of things. Uh, so here we are going to okay, we're gonna pass the state, but is this state that is the one until that point. For the data set, we're gonna pass the ideas uh, valid, so the validation data set, and here we are just going to pass okay, we have to create a validation step actually. So let's just copy this. And the validation step is usually super simple. So usually something like test step.
You
So
copy.
it's the same. It's just that what is inside the loss function uh, can just execute it outside. And then we don't need any of this. And okay, we do need to add something. And is that instead of calculating the accuracy like this, we need to use our metrics that we have there. So it's something like this uh, metric updates. So this is state dot metrics
Update.
dot of the API is from model output. And then here I think it's this. So we have to pass the logits, but this has an API that only accepts named arguments.
Linus. Hmm.
So we pass the logits, we pass the labels, and we pass the loss. So Logits and labels go to accuracy. Loss goes
Kudos.
to loss, and it's specified as loss because we gave it the name loss here. So if we give it the name loss here, it will expect the name loss here. So
Loss.
CLU specific
Sí.
stuff, but once we have the updates, uh, we we can do something like this. So okay, in the logs we don't need to. So there's a thing called stateful metrics, and okay, so we can add one by one. Uh, so let me just show you the full thing, but I think we're running out of time.
Hmm.
Uh, the API for CLU is something like this. We run compute on the metrics, and then we get a dictionary of loss and accuracy. And then we could pass this to stateful metrics, something like this, accuracy, and then the same for loss. But there is a shortcut because there is you can just pass many. Uh, you have many values, you can pass many values at once. And if we wanna save another line, we can just do this. So okay, okay, one thing. Okay, no, we're not done actually.
What?
These are sorry.
No, no, go for it.
One thing is that actually these values are just for the current step. We need to merge them with the information from the other steps. So we actually have to recalculate metrics as state.metrics.merge. So we need to merge the updates,
Hmm.
and then we calculate the value using like the merged uh, values. Uh, so a little, yeah, this CLU stuff, but it's not hard. Just maybe new to to doing this. And okay, we're done. I think we need to do this also for the. We need to do this also here. Uh, oh, and we need to replace metrics with the new metrics. We also need to do this here. So we updated metrics. We need to update the metric state. Okay. Uh, let's move this here and remove this. Yeah, this is the new way we're calculating things. Uh, it's a little cumbersome, but uh, now we have a stateful metrics, which, as you'll see, the plots now will look much better. So, okay, what are we gonna do here? Every step called a test step, uh, and we have to do something else. There's some things that you can call on start, and on start we're gonna call reset metrics.
So every time that we go in there, we'll set the metrics and everyone will do the test and it's a loop. Okay, makes sense.
Okay. Yeah. We call this outside here. Uh, yeah, on start. So when the loop starts, it will reset the metric. So this gets new metrics. Um, okay, no, actually, we can do this different. Uh,
It's okay, no?
so yeah, no, that's okay. But we also want to reset the metrics for the training state. Now that I remember, so what we can do is uh, first reset the metrics in general. Like this will also reset the metrics for here, and then this inner loop will start with fresh metrics. But the key is that this inner loop will update like its own state because JAX is immutable. Well, because this stuff is immutable, these updates here
Hmm.
they won't affect outside. So this just doing it here works for the training uh, logs and the validation state. Okay, one more trick. The, I mean, this is what I say that the training loop is like a language. These callbacks, if you're gonna run them every step, you can also destruct them. So they look simpler. You cannot do this here because it's just a function, but this thing implements the destructuring.
It's
So
because
okay,
it's the type mutable, what? Right? Well, we saw a few minutes back.
it's because this thing implements mapping. So
That's it. Sorry. Mutable mapping. Yeah, makes sense.
okay, let's see. I'm not sure we're gonna get this right on the first run. Let's see if we get. Okay, yeah, we're not gonna. Matrix has no from model output.
I think
Let's
we wrote that up. Uh,
has no from model outputs. Ah, okay. Has a slightly different name. Let's just see what collection names it. Yeah, I don't like this. I think it's single from model output. I don't like this. There's like a collection has a slightly different API than metric in some places. It should
hmm.
be this. Okay.
Yeah, makes sense.
So okay. We trained, but now we get an error in our validation.
Error loop function name params is not defined.
Okay, yeah, that makes sense. So here is state.params. Okay, another error. Let's see. Okay, same
You have
same
the same thing.
same error. It's this one. Okay, hopefully, okay,
Yeah,
yeah. We
makes
get
sense.
the accuracy, and now we get also the validation accuracy and the validation loss. Uh, so we get both,
Cool.
and obviously, yeah. Like as you see, things are very configurable, but also then it's a little bit more verbose than in Keras. The upside is
Yeah, everything is manageable into their own state, so you can do like very parameterized stuff. It looks like for me at least.
yeah. Well, this is just kind of creating the training loop. Remember that you can also just code in Python.
Hmm.
I think the important thing is that it's like it's very flexible. The definition of the training step, which is part of the loop, is very flexible. So you can do almost gonna venture to say anything that you can do in JAX. So you're not limited in elegy and that kind of stuff. Like if you have a predefined like API that is not functional, usually you get a lot of constraints. So this is more of a like functional first, and because it's functional first, you can use a lot more of JAX tooling.
Hmm.
And okay, yeah, let's see where we got.
The collected.
One thing is that we okay. I am a bit surprised.
Hmm.
Okay, yeah, no, it's okay. We don't need to do anything here. So first thing, now they're a little bit more, a little bit smoother. The jumps are when you reset.
Hmm.
At the beginning, you get like a jump uh, when you reset the metrics. You can erase this by simply not resetting. Uh, so that is one thing. Or maybe yeah, you can just plot instead of accumulating, you plot only at the end of the a little bit better would be to only collect the metric every at the end of the epoch. That would make this look, yeah, a little bit more like, well, you have
Yeah,
less
like what I
points,
expected.
what you usually expect, but
Hmm.
yeah, we don't have that much time. Second thing is that we can actually plot like this is losses and this is lo- losses valid, and then etc valid, and it's just okay, it's not quite this is the name we had here. uh, so loss valid, accuracy valid. Yeah, and then here uh, we have this. It's just also plot those is valid. Should probably give it like
Different.
a
Yeah. Token.
I forget the thing. Is it called name tag?
Uh,
Let's see.
let's see if someone on the.
Able. Okay.
Uh,
Train valid. And then do the same here, please. Yeah. So
yeah.
okay. If you notice this, this didn't do it in the first one. Every 1,000. I'll be curious why the validation loop doesn't run on the first one. I think it might be a bug, but it should run on the first one.
Hmm.
uh, yeah, of steps, subset. Let's see, -1 maybe. I think this is probably like a bug. Uh, but it should run. Let's put it like
And the
this.
first one. Oops. Oh,
Okay, let's stop this. Stop. Okay, decided to finish. Ideally, it also runs on the first one. Okay, yeah, we got it to run on the one of the first ones. Uh, yeah, that
hmm.
way we get a little bit more points. And okay, yeah, I think we're almost done. I don't know, David, you have a question?
No, not yet. I think it's cool. There are a few things that I wanted to try, but I think the time is not is not on our side for this one. Yeah, look at that.
Oh, we forgot to show the uh, legend. Okay, yeah, they look very
Swindle.
similar. We're not overfitting, but that's kind of what you expect. So yeah, I think that's it. I think maybe when we went a little bit ahead because of the complexities of creating like a proper validation uh,
Split
split,
step
but
step.
this is more or less what you get right now. I think this is fine for now. In the future, I
Well,
want to.
I would like to see that in the future we can see the thing with the distributed logs that automatically can collect.
Okay, that is implemented. Maybe we can view it in a future stream.
Hmm.
It's experimental. It's called the managed API.
Hmm.
So you can create like a state, but um, you can decorate your training step with a like a special function that does a couple of stuff for you. It simplifies the coding a lot. So it looks a little bit more like PyTorch Lightning actually.
Hmm.
So that is one thing that that is there. It's, that maybe we can cover in a future stream. I've also been thinking of ways to simplify. Yeah, okay. I don't know. I think this is more in the future because I don't want to do it too early. But
Hmm.
maybe creating like a Ciclo.fit that does a lot of this boilerplate. If you have like a
Atraneas.
thing that behaves like a more of a regular schedule, and maybe also open the hatch such that you can have both like a regular like basically a lot of predefined we have the outer loop and we have like the inner validation loop uh, and a couple of on epoch end and that kind of stuff.
Hmm.
So this could be simplified
Quite a
uh,
lot. Hmm.
quite a lot. And I'm also thinking of adding framework support. So maybe all this that we did here of creating like metrics and the state. Um, so yeah, basically a way if you have like a framework and you want to have something like a predefined training step. I mean, this if you're going to do like more yeah, the more common stuff, yeah, you're not gonna do like maybe a complex training loop. You're just going to do some more of a supervised task,
Hmm.
kind of like, yeah, Keras or PyTorch Lightning. Then maybe you just give, hey, this is kind of my Flax module, and these are my CLU metrics, and these are my losses.
And then just there is a boilerplate that do the sticking for each metric, for each loss, for each
Yeah,
stick.
maybe automate this, creating the training step for that, and creating the test step for that. A little bit of automation and such that you get like a state that knows how to to update, like, yeah, basically automate this. So I'm thinking of a few places where if you're going to do the most common stuff, you can do it, but in a way that it is optional. Like, okay, because you always have this. It's just okay, which shortcuts could we take?
Hmm.
And then, yeah, that is kind of things that I'm thinking about. But anyways, yeah, Ciclo, very early stage. If people out there are gonna try it out, basically, I don't know, yeah. If it breaks, reach out. Uh,
Put some reproducibility there.
Also, if you have ideas, stuff like that. I mean, this was more of a personal library, and I worked on it until I felt okay. This is ready for the public,
Hmm.
and I think it's in a usable state. So, yeah, feel free.
Awesome.
I think we can leave it at that, uh,
Hmm.
Mr. David. Uh,
No, that's it. Thank you very much, Mr. Christian.
yeah, use it and tell me how it went.
Right, perfect.
And yeah, I guess next stream we go back to the flag stuff when people are back from holidays.
Yeah, for the distributed stuff actually. Well, I think that we could do the Cyclo. I really want to see Cyclo with the managed API.
Yeah, we could dig into like the shortcuts, that maybe these videos serve as documentation.
Hmm.
That would be nice. But yep.
All right.
So so I guess, see you on the next stream.
All right. So see you then.
Bye.
Bye bye.